Hey, I'm Elisabeth Hendrickson, and I'm here today with Onsi Fakhouri. Onsi and I worked together ages ago at Pivotal,
Hmm.
where Onsi was the SVP of all of R&D at Pivotal. Um, and what I was hoping we could talk about today is actually something that goes back before you took on that role, all the way back to starting in 2013, actually, when you were working on Cloud Foundry. And at the time, as I recall, you were a very, very senior level, but individual developer working on Cloud Foundry. And I should back up and explain. Cloud Foundry is a platform as a service for cloud native applications. And so as a developer, all you have to do is say CF push and your app is live. And in fact, Anzi, I did bring some swag.
Oh, really?
Yes, I did. Does this look familiar?
Oh my goodness. It lives on. Here is
It
my
lives
source code.
on.
Run it on the cloud for me. I do not care how. That's right.
This was
That'd
your
be,
haiku
that's right.
to
That's
explain what
right.
Cloud Foundry does.
That's right. Yes. Oh my
I love
goodness.
that haiku. Oh,
Thanks.
I have kept that shirt. It doesn't fit anymore, but I
I
have
know,
kept
right?
that shirt.
Love it.
So if we look at what Cloud Foundry is inside, it's a massive distributed system that provides everything an application needs, from data service brokering to workload orchestration to networking to observability. So it's this
Hmm.
massively complicated thing. But from a developer's point of view, it's incredibly simple. And if we go back to 2013, the core guts of the system, especially the Droplet execution agent, the DEA, the thing that was responsible for actually hosting these cloud native applications, it wasn't meeting the needs of organizations,
That's right.
including our organization, which used Cloud Foundry. And you had an idea for how it could be better.
Yeah. We felt, I think, pretty stuck. We had this old Ruby code base that we had half built, half inherited that was starting to keel over. There were serious questions about its capacity to scale. And I think more importantly, the thought of adding a feature to this thing, you know, like it was hard. It was very, very hard. And it increasingly felt like it was just the wrong language. Rarely is the answer you're using the wrong language. I think in this case, it had become pretty clear that we were using the wrong language. And the language we were using was Ruby at the time. And so the decision was made to rewrite it in Go, which was the new hotness at the time, and very much so the like distributed systems hotness. And we were like, okay, let's give it a go. Let's try this out. And we actually had a test run. Like, what does it take to rewrite a thing that's written in Ruby in Go? Just before we took on the DEA and all of the complexity of that massive distributed system. And the first thing we did was we wrote this little component called the health manager, um, which we don't have to get into the details of why, but that was an interesting exercise in sort of meta learning. Like, how does one rewrite a thing within the context of a distributed system and then upgrade the distributed system so that the new rewritten thing becomes the new thing that everything is using? And so in about 3-4 months, we went from health manager written in Ruby to HM9000, which is what we called it. If
Oh,
you
I had
remember this.
completely
Hmm.
forgotten
That's
HM9000.
right, right, written in Go, and that was sort of the organizational prototype, so to speak, of like what would it look like to do this. And interestingly, we took some of those lessons and adopted them, and we took some of those lessons and set them aside as well when it came to taking on the bigger thing. Yeah,
I have so many questions, but
I know, I know, right?
I want to pause and
Sure.
highlight something that you just said, because I don't think it's something that many organizations would think to do. You took a tiny, tiny tractable problem, and you were really. It sounds like with the intention of learning about the much bigger, hairier thing.
Yep.
So many rewrites fail. And
Yep.
in so many cases, I can imagine having a conversation with leadership, and leadership basically saying, we're not going to go rewrite this little thing that doesn't matter as much. That's not where we want to invest. But the investment wasn't about getting a new health manager.
Right.
How did
Right.
you know what you needed to test? Like how did that conversation come about?
Uh, Specifically with health manager and like how to approach it. If I remember, this was 11 years ago now,
I'm
but
sorry.
that's all right. Uh, I I think I we spent the first me and my pair and I spent the first 2 weeks just understanding the thing. And to understand it, we built a test suite that was tracking the like black box external behavior of the thing in a way that allowed us to have an increasing sense of confidence of what's important, what matters, and what are those messages looking like. And the goal was to do a totally transparent in-place replacement of this thing, right? So no new features, pixel for pixel, if you like, rewrite of the thing. And in order to have confidence that we had done that, we bootstrapped this test suite and then started to build the new code from underneath it. And as you can imagine, this was an integration level suite. This was like the highest level, like, you know, data in, data out, does it work? And went down that road and pretty quickly had a replacement, and then went through the process of thinking through how in the world do you get this thing into a running distributed system? What does that crossover transition look like? How do you deploy it? Now, to set the stage, it's one thing to deploy it when you have complete control and you run the ops team. But what Cloud Foundry was, what the promise that Cloud Foundry made was that the customer was running this distributed system behind the scenes on their own infrastructure. And we gave them relatively simple, I'm sure many customers are now looking askance as they watch this going, what do you mean? But anyway, relatively simple procedures to like upgrade, right? And our goal was that those upgrades would be no downtime for the applications and fairly seamless, and again, relatively simple, not crazy complicated. So how do you do that? Those were sort of the key things we wanted to learn. Like how do you wrap enough test coverage that you have confidence that you've built the new thing, and then how do you test it internally to make sure that it's working, and then how in the world do you then ship that to customers and in a way where they can deploy it by pressing a button as opposed to, you know, doing a lot of internal plumbing that they shouldn't know about, right? So yeah, those were sort of the chief goals and the things we wanted to learn, and a lot of those ended up helping us out when we took on the bigger project later. Yeah.
So you said that you learned some things that you applied, and then you
Yeah.
learned some things that you set aside. And I have so many questions about the set aside, but I want to
Yeah.
start with what did you learn that turned out to be super valuable, and it was a really good thing you'd done the little project first.
Yeah. I think the the big lessons for me are integrate early, live side by side, and don't skimp on the integration tests, right? And like fight the flakiness, you know, like really make sure those tests are telling you something about reality, and that you can trust them and that you can lean on them. So uh, integrating early, it 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 would have been really hard to do this in a vacuum, and then even that smaller project, then 3 months later be like, here you all go, let's try it for the first time, right? Obviously this is crazy. So instead,
Good luck with that.
right, good luck with that. Right. So like, how do I spin up the entire distributed system as locally as I can so I have a very fast feedback loop? And then how do I have the old component sitting alongside the new component? And then how do I slowly start to transfer traffic to the new one? Or how do I have an A/B environment where I have the new one and the old one running side by side? In addition to all of the tests that are sort of more pre-baked, right? That are wrapping the new code. How do I get to a world where it's alive and I can poke at it? And if it fails, I can look at A and B and go, okay, what was the difference there, right? And that takes a lot of work and a fair amount of discipline, and is almost always worth it. Like, and developing the tooling to make that kind of work easier and easier is a good investment, right? And so out of this comes the testing framework Ginkgo for Go, right, which was all about running integration suites in parallel at scale very effectively and efficiently. It was all about writing expressive tests for asynchronous testing, all of this sort of stuff that like emerged from going through that experience in the small proved to be very valuable in the large. But you're going to hear me say this again and again and again. The central principle is fast feedback loop. Find a fast feedback loop that connects you with reality, right?
Yep.
Like, yeah,
100%.
yeah,
Um, you did mention integrate early.
yeah,
And I want to understand how early. Like I can imagine a world where early was the minute that it could do that HM9000 could do anything that the health manager would do, you could start running it side by side.
yeah.
But how early do you really mean?
Um, there's sort of there's even multiple senses of what integration means, right? There's like integrating it in production, there's integrating it in some sort of staging environment, and then there's integrating it locally on your box, right? It was integrated locally on the box within the first week, right? Like that was key. And again, to me, it's about that fast feedback loop, right? I'm not going to be in production for a while. I'm not even going to be in staging for a while. Just locally, can I spin up the world and have everything that I need in order to test this thing? And so that was pretty early on a thing that we did. And then I think those outer shells, they came in. I think the project took 3 to 4 months, and within the first month, 6 weeks, we were running in staging, is what I remember. But I may be misremembering. In any event, yeah, early and often, but also with an emphasis on locally early and often. And if you do that, you buy yourself time to solve the more gnarly, like how do we get this running in a different environment, and then how do we get it upgraded in production? Yeah.
You
So
talked about you and your pair. Was it just two people on HM9000 or was there a larger team?
it was just the two of us, and I think my pair changed a couple of times because we were rotating
Oh,
pretty heavily back then. Yeah, yeah,
totally.
yeah.
But
Hmm.
tiny two-person rewrite, four
Tiny two-person
months.
rewrite. Yeah,
Yep.
yeah. One of those things where like all the context was largely in one person's head, so you can move pretty quickly. Yeah.
You mentioned lessons that you set aside. Was that because you realized they didn't apply, or was that because other stuff happened? What lessons got set aside?
Maybe set aside is not quite the right way to frame it, but more realizing that uh, a strongly held opinion was more an adjustable knob. Okay, specifically, the strongly held opinion was pixel for pixel, add nothing new, don't make a change upstream, just be a drop-in replacement, right? With a small component like that, like the health manager, that made sense. With the timescale involved, that made sense. There was no sense of that organizational pressure of what are we doing here? We're not actually making progress while we're doing this rewrite. Um, with the bigger thing, when we got to doing Diego and replacing those droplet execution agents, we didn't want to just do a rewrite. We wanted to do a rewrite, but we also wanted to add some features that we desperately wanted to add. And in a sense, that was the business value. There were like two layers of business value. There was like, get us to a place where this thing is more solid and stable and understandable and changeable. But also, please, like, add these things that everyone wants. And can we do both? And 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 that's a risky decision, right? And why do so many rewrites fail is probably several PhD dissertations waiting to be done, right? And I can totally imagine coming out of that some sort of consensus wisdom around thou shalt not add new features while you rewrite, and I get that. But when you fold in the human political element of the organizational appetite to just wait, for the development morale around, okay, what did we just do? Are we in a better place? Do we really know that we can move faster now? That we can add new things? I think it's a more nuanced decision. And it becomes about really thinking through what are the bits that we don't want to touch and what are the things we want to be adding incrementally. So that's one piece, and then the other piece was the thou shalt not touch the other components. That was not going to be feasible once we were at a larger scale. Like the whole infrastructure was the whole architecture was like kind of weird. And we were like, maybe let's unweirdify some of it. And so that turned into this really interesting exercise of like, well, that team over there owns this piece and they're in production and they're adding features. And here we come building this thing that someday will be real. May we please have access? May we please, how would you like us to, what should we do to work? How should we just submit a PR? All the conversations. But you have to, you know, we had to do it and we did it. And so those two things were more in scope, I think, than they were with the first experience with that smaller piece. Does that make sense?
It does. In fact, you said something that I want to pull on a thread a little bit. You said all the way back at the beginning that one of the motivators to rewrite DEA was the feeling of, oh, we have to add a feature to this thing, and it's really hard to. It's not what Brian Merrick would call malleable code.
Right.
And then you just said, if we don't try to add new features, how are we going to know if we achieved that objective? And that to me is kind of fascinating. And so now I'm curious, what features did you pull on to add, and do you remember, I know it was a long time ago, but do you remember any lessons learned about how to structure the code to be more malleable?
In a sense, it was less about structuring the code and more about validating that the architecture we were ending up with for the whole distributed system was one that would allow us to add these sorts of features. So for example, giving end users SSH access all the way down into the container was a thing that was really hard with the old code base, but a thing we wanted to do. And could we do it with a new code base? And could we make that one of the early things that we deliver to prove that we could, and also to generate, again, politics is, maybe word politics isn't the right word, but like the sense of like, we're making progress and there's something to rally around here and it's exciting. Like being able to show that demo early on was a really powerful thing, especially because when you're doing a rewrite, the first 80% takes 20% of the time, and the last 20% takes 80% of the time, and like that classic rule of life applies here. If you can make that first 80% interesting, compelling, have positive properties that people will rally around, then you will have a little more air cover and buy-in to get that last 20% done.
So that's really important wisdom right there.
Yeah.
Because what you're describing is kind of I have seen plenty of organizations that started a rewrite project and then just kind of lost the conviction around the thing. And I think of it as the point where you hit the thing that feels like a slog, and it's the messy middle. And so what I'm hearing you say is that this approach enabled you to get more support to get through that messy middle. But I was curious about, can you think of a time when it did actually become a slog, where that last 20% that's taking 80%, somewhere in there, it just feels like, oh, we're stuck in the tar pit. And how did you get through that messy middle with Diego?
Yes. There were many messy middles. One of the interesting things we tried to do, so we tried to explore different ways to do distributed system scheduling, right? Like how do we decide where those containers all land? So to maybe step back, what are we building here? We're building a container orchestration layer that takes input from sort of the outer API shell that says, hey, these are the apps I want running. Please go run them for me. And the orchestration layer says, cool story. Let me take all those apps and I will take care of spinning up containers across this set of VMs that I have, and I will take care of making sure that they stay up, and I will take care of balancing resources across them, and I will take care of all of that for you. You're welcome, right? For those who are familiar with this space, the word Kubernetes is the one we use nowadays for that thing. When we started Diego, there was no Kubernetes. Kubernetes hit 1.0 right around when Diego hit 1.0. So these two things emerged in the world. In any event, we were trying lots of different experiments to explore what are some ways to distribute those containers, to schedule them, to orchestrate them, to monitor them, to keep an eye on them. And, in retrospect, we tried some things that were, I think it was worth trying, but proved to be not viable. And going through the experience of that cold sweat experience of, oh, maybe this won't work. And not like the whole thing, just this one aspect of like how we're going to schedule these containers and this approach we've taken. This is not working. We're going to have to try something different. And oh, by the way, we'd like to ship, right? How are we going to do that? What is that going to look like? And this is where it just got really hairy. For me, at least personally, I had this idea to do this distributed scheduling thing, which seemed really cool. It was sort of a mishmash of ideas that were in the industry at the time, and it worked great at a small scale. But we knew that some of our customers needed to hit ridiculously large scales, and as soon as you turned that knob, it stopped working. And finding out early that it wasn't going to work was a very important thing. And so we ended up, I know we want to talk about this eventually, but the solar simulation driven development thing came out of that problem space. But then when when reality spoke back and said, nice idea, nuh-uh, that was a bit of a scramble to figure out, okay, how are we going to adjust? How are we going to figure this out? But to circle back to your question, the promise of like all of these cool new features that we were going to be able to deliver, this more malleable architecture and infrastructure we're going to be able to ship, you power through. And in a meta way, the fact that we were able to totally change how we did the scheduling within a couple of months and resolve all these problems speaks to the value of the rewrite, which was that you could make that kind of change at a fundamental level, and it didn't take you forever, and we were then able to ship.
There's so much I want to unpack here. So
Sure.
let's take a step back and talk about test-driven development, which at Pivotal we were incredibly rigorous and disciplined.
Yes.
About test-driven development. And you kind of alluded to that with the HM9000 story when you said you wrote this set of integration tests, and then that was the set of tests that the new rewrite had to be able to pass, right?
Yep.
Okay.
Yep.
So I remember the first time that I heard you say simulation-driven development, and my brain just exploded with the possibilities. Tell me more about how you arrived at the realization that you needed to do a different flavor of TDD, and then what it looked like, how you went about it. Tell me all about simulation-driven development.
Sure. Again, it comes back to feedback loops. And how can I get a fast feedback loop? But more importantly, how can I get a valuable fast feedback loop that ties me into the aspect of reality that I need to be confident that this code will work? And that's, at the end of the day, we use the word TDD or tests or unit tests, integration tests, simulation tests, whatever that means. Like, it's all about what I just said. Give me a fast feedback loop that connects me to the slice of reality that I need to be confident with what I'm working on. And so unit tests, especially well-written ones, they're connecting you to that more granular, itty-bitty logic, level detail of how does this particular component work or not work. Higher up are like these sort of within a code base integration tests that help you understand, do these components work together, right? And they're tying you into the reality of, is that connection working or not? And then higher up for us, we were a distributed system. So we had lots of programs that were trying to communicate. And so those unit tests and then those integration tests were not enough. It's not enough to say A works and B works. You also want to make sure that A and B work together. And so we had another layer of integration tests that existed to make sure that the system as a whole worked correctly. We ended up, in a context like that, you will often end up in a very painful place where you don't have a fast feedback loop, where the only way to run those tests is to deploy the whole thing in the sky and then wait for it to deploy and then run the tests. And we didn't want that. And so what we did was something very different. We had an integration suite called Inigo, INIGO. Integration for Diego somehow is how we got to Inigo.
I'm pretty sure it's a backronym, and I'm going to be asking you about naming
100%.
later, but keep
Oh,
going.
let's not. Yeah. So in Ego, instead of spinning things up in the cloud, it would just locally spin up these executables, and they all had a mode where they could run locally, and then it would test them locally, and it ran really, really fast, and you could parallelize it, and it would run incredibly quickly. And so in 3 minutes, we would have all of these correctness tests about the the uh, the components working together. And then we realized we need another layer of tests that handled the weird edge cases, and so we built a framework called Vizini, uh, for inconceivable tests where like there's no way that this could happen in real life,
That word
but
does not mean what you think it means.
exactly, but it'd be worth covering these in tests. And so we would spin up just these subsets and then feed them weird data to make sure that they would succeed. And that was all good. And those two would give you correctness in the normal mode and then correctness in the weird edge case mode, right? But then there was another layer that was missing, which was a combination of performance and scalability, but also like, do the emergent properties of the algorithm that is doing the scheduling actually match what we want? Which is a very weird thing. And what was interesting about performance was that it would kind of work locally, but once you deployed it and had it running in the cloud, all that network latency would actually break things and would actually change the behavior of the algorithm because that introduction of lag would cause problems. Okay? And so Fezzik was born. Fezzik.
I've forgotten all of this.
And watching the Princess Bride was like a key part of onboarding on the team by the end of it. But Fezzik was born because what Fezzik would do was spin up locally the components. It would spin them up locally with the capacity to introduce noise into their communication to simulate network lag, and then ultimately it would also SSH into machines and spin them up on a real network to test, like, what if I actually do this in real life? And it could do this very, very quickly. And that was the simulation piece that connected us to this feedback loop of, does this crazy scheduling algorithm work? And does it work locally? And if it doesn't there, then it has no hope of working in a distributed context. Does it work locally plus lag? And if it doesn't there, then it has no hope in a distributed context. And then does it work in a distributed context? And you could tell based on what was failing, where you needed to look in the code and how you needed to think about the problem. And it would run and it would generate these. It wouldn't fail or pass. It would generate graphs. It would generate distributions of containers across container orchestrators, right? Like it was more science than Boolean yes or no. And to interpret the results, it entailed looking at these things and staring at them. So it wasn't the sort of thing you put in CI and it would go green or red, though it had some of those aspects to it, like how long did it take me to schedule all of this stuff? It certainly had that. But the value in it was being able to visually understand, okay, this is how stuff is getting distributed. Does that look right? Is that working? Is that good? Is that bad? Are we leveraging as much of the infrastructure that we have, or are we ending up with weird hotspots? And so those were the pieces we ended up with. And I just walked you through the whole layer cake, right? And it took that entire layer cake to ship a thing that we could be confident in, and it took that tippy top piece to get the feedback about 4 months before we shipped that this wasn't going to work. We were going to have to change it.
Which is amazing.
And we changed it. It was really cool. Yeah. It was very validating to see that signal. We don't, in science, there's this null hypothesis problem, right? Where people don't publish null results, where you try an experiment and it fails and you're like, oh crap, I can't publish this. No one's going to take this. But those are really important. only if you know what doesn't work can you go figure out where to look elsewhere, right?
I'm picturing the airplane right now with the bullets. Yeah, exactly.
Yeah, exactly. Yeah.
So, simulation-driven development, there was an expectation. This is where things get really interesting from my point of view as we start to look at AI is creating us and I don't mean using AI in development or test tools. I mean building things that have LLMs baked into them that provide value. But the thing that chunk of code is doing is not deterministic.
Yep.
And so when we start to look at what is going to be shifting in the industry, I am convinced that we're going to have to come back and relearn a lot of lessons about how to do really good testing, and specifically test-driven development.
Yep.
What does that look like when you can't say input, expected output?
Yep.
And you just described having some expectations about what should be true about the shape of a thing, but the thing itself, there's a range of valid outcomes that you were looking for, but there were also some things that, like, it shouldn't look like the thundering herd problem.
That's right. Exactly.
So tell me more about the simulation driven part. Like, how did you form your hypotheses about what stuff should look like? And then the TDD cycle, you know, express your test, you write your code, see it pass, and then clean it up. But what did that cycle look like for simulation driven development?
In some ways, not very different. Now, I think maybe it's a bit of a stretch to say it was truly driven. There's a sense in which we got to the point where it was working, and I was like, is it really working? I'm going to answer that question not by poking at it alone, but by building some software that will poke at it for me. And oh, look, I can run that again. Oh, look, I can run that again. Okay, great. That's a test suite, right? Once that test suite was in place, anytime you change that scheduling piece, the first place you would look, well, the first place you look is the unit tests and the integration tests, like, is everything working? But then after that, you don't just deploy it and then poke at it, you just run this simulation. And that will tell you how things have changed. And the sooner you can do that with making the change, the sooner you can make that connection and understand, okay, that did this. Is that good? Is that bad? Is that neutral? Rinse and repeat. And so you back into that same sort of cycle of like that the TDD gives you, but we kind of backed into it retrospectively, I suppose. But whenever there was, you mentioned the thundering herd problem, we had that. We had one deployer who was like, that was interesting. Can I add a test to understand why that happened? Oh, I can. Can I fix this now? I think I did. Let's deploy that. Exactly, right? Like, hooray. So we ended up in a world where you did have that experience for the most part. But yeah.
I was not deeply involved in any of this and
Sure.
might be misremembering, but I do actually remember, and this is why when you said simulation driven development, my head exploded with just the possibilities. It was amazing.
Yeah.
I'm remembering the time when you were still experimenting with different algorithms for workload placement and had the auction concept.
Yes, that's right.
And you actually did. You were genuinely driving with the test. It's just that the test itself was a shape that you expected to have
Yeah.
on the graph.
Yeah. Yeah.
So I'm remembering right?
You are remembering right. So the fuller story is there was like the V0 of that auction thing, and it was just enough to get us working, right? Again, fast feedback loop. And then it was like, okay, I bet we can make this more sophisticated. And that's when all of this comes into existence. And then that thing got more and more sophisticated, and it worked until you increased the scale. And then it would hit all these failure modes because there was this hidden n squared term. That's and so we ultimately walked away from that and then had a more deterministic, centralized algorithm, which is more traditional, which is what's in the bowels of Kubernetes, right? Which is basically the easy way to do it. And we didn't need the fancy auction thing, but we learned that, we learned that, and that was an exciting thing to learn and see and be able to adjust in real time. Yeah.
You're reminding me that one of the themes that I learned from working on Cloud Foundry has to do with when fancy isn't going to get you anywhere near where you need to be. Because speaking of thundering herds, I recall discussions about the way that the router worked, and that it turned out round robin was not only the simplest algorithm, but also prevented a whole bunch of issues that really smart algorithms would have with thundering herd.
Yep, that's right. Yeah.
And simple is better.
Simple is better, and that's not always the case, but it often is the case. And this is where those simulational kinds of tests can give you that kind of feedback, right? Because you're not so much after correctness in the logical sense in the small, you're after emergent properties that will surprise you. And the only way you're going to get at those is to poke at the thing at a scale that is different from the original design. Yeah.
I'm 100% convinced that if you hadn't come up with this way of doing simulation development, we never would have shipped Diego.
Yeah, or we would have shipped something that had some seriously scary emergent properties that we would have only noticed when customer that shall not be named installed it and kaboom, right? So yes, yes, and that would have been uh, I, very challenging for the company, right? Like you lose credibility, you lose trust if you do that
We
too
were also
much.
comparatively small.
We were also comparatively
And
small,
so I don't know how we would have dealt with the
right?
pressures of having to fix a bunch of stuff in production and still move forward, given
That's right.
we were
Yeah,
comparatively small. I
yeah,
mean,
yeah,
at
yeah.
the absolute peak, R&D had like 700 people, I think. Is that right?
Cloud Foundry got that big, yes.
Okay. And then
All of our,
R&D as a
all of
whole.
R&D was about 1,000 at its peak.
Okay.
Yeah, yeah.
But still, like you compare that to
Sure, like
thousands of
Google or
developers
whatever,
and
right? Yeah.
yeah, so comparatively small. I want to change gears a little bit
Sure.
because you actually took on a role that I think many people would find surprising in leading this initiative. Technically, you were the product manager. No, you weren't?
I
Yes, you
was
were.
I was in title.
Yes, that was your
Yes,
title.
that was my title. I think what I was doing was more of a technical lead,
Hmm.
right? So,
Oh,
and I
we agree, but
yeah,
I got a point that I want to make
please
with this. So
go
keep
for it.
going.
Go for it.
But no,
No, no,
you
no,
were
no,
going to say something.
no. That's all I was gonna say.
Okay. So so I need to back up and explain for people who didn't work at Pivotal the role that a product manager on a team played. They were embedded with the team, and they have the product managers who work this way have the responsibility of listening to the cacophony of conflicting demands, distilling that into a vision for how to move forward, and working with collaboratively with the engineering team to slice and sequence the stories. But ultimately, the product manager decides what and in what order,
Right.
and the engineering team decides how and how long it's going to take. So that was kind of the division of responsibilities. Now,
Yep.
I'm not disagreeing with you. And when you characterize your role as, you could say, technical lead, chief architect, the whatever words you want to
Right.
put on it. But you were actually doing that, listening to conflicting demands because you had a bunch of constituents,
Yep.
and you did mention the things that everyone wants. Well, this is part of what a product manager does: is figure out what does everybody want, and then figuring out how to slice and sequence. And so I was curious if you could talk a little bit about that side of the role that you played, because I think that you made some really interesting and important and smart decisions about how to steer the development effort, that might be, because it was informed by that product management discipline, might be a little bit different from the way that another technical lead might go about a similar kind of thing.
Sure. Yeah. The reason I hesitate to say that I was a product manager was because if a product manager isn't talking to like the actual customers, they're not really a product manager. And I was not super deep in talking with actual customers when it came to this rewrite, and in part because we were this thing under the hood, and one of the things we wanted to do was, yes, we were adding some features that, yes, there was plenty of customer evidence for, that basically was pointed at me by various intermediaries who were talking to customers, so that existed, right? But like at the end of the day, what we wanted to accomplish was customers in a single or maybe two rolling deploys got the new stuff and didn't notice anything other than a bunch of new features turned on, right? And so much of the emphasis and the effort was like, how are we going to do that, and how are we going to figure out how to build this thing in a timescale that's feasible and reasonable, and help customers get from point A to point B without going through the valley of the shadow of death, right? Like how are we going to like actually succeed in doing that? And that constraint was liberating, you know, in many ways. It was like, okay, so that means We can't change the external API. We don't want to. That means, or if we do, we're going to have to do it in a very, very controlled and well documented way and keep it to the minimum, which is what we ultimately did. Um, that means we can't just take options like deploy a second Cloud Foundry over here and then move everything over to it. We wanted to do it completely internally, right? And that means we were going to have to solve some really interesting migration problems, and that's going to inform the architecture, and we're just going to have to do that. And it sort of collapsed the set of options pretty quickly, and that was in many ways liberating, because it's like, okay, now we're going to go and do this. And then it became a question of sequencing and value, and as I mentioned way at the beginning, like, how quickly can we get this running in real life so that we can see if it's working? And those became sorts of like the pillars that we were aiming for. Like, how can we get it working soon, locally, in our staging environment, in early access customers who wanted to sign up for a beta, and how can we add enough interesting, exciting features that we wanted to ship in a way that would get us buy-in from customers, get us buy-in from the rest of the organization, help us feel like when we woke up in the morning, like we were doing something cool, you know? Um, and those were, honestly, those were the kind of the guiding principles that were directing the decision making, such as it were. And yeah, and and also we allowed ourselves the space to learn and make mistakes. I think this is really important. Like, I'm thankful that, yes, there was pressure to ship, but it wasn't like you have to hit this date, otherwise, like, that would have just, like, we made mistakes, we learned as we went, we deleted code, we added new code, we changed the underlying database. We so many things, and some of them even after we'd shipped, because we actually got good at making crazy changes to a distributed system that isn't even within our four walls. Like, we learned that skill, which is so cool. Um, and having that freedom to like explore and learn and fail was really, really important, and something that uh, it relieved the pressure on me personally to be like, I have to get the decision exactly right, because you can't, right? Better to make the wrong decision and learn that mistake and then fix it in a context where there's not a lot of angst or fear about doing that, than to be paralyzed with, should I make, what decision should I make? Um, I don't know if I've answered your question, but that's sort of the texture of what it was like in that role, and the things that were informing it, and yeah, the principles that were guiding it.
Totally. No, you did answer the question. And one of the things you just said, change the database. I also forgotten that detail. You applied what I would call options thinking
Mm,
to the design, where there was a point where, is it going to be etcd or is it going to be Zookeeper that's going to keep internal state? And you kept the option open by supporting both until it
that's right.
became very clear which one.
That's
Ha-
right.
that is not something most organizations would necessarily, because it costs time to
Yeah.
keep both
Yeah.
APIs in the internal system.
Yeah.
How did you know that was the right thing to do?
In a way, it was a weird lesson from the previous code base, which was very much hard coded into the decision that had been made around, in that case, a message bus. There wasn't an abstraction between the code and the message bus, so like changing things was really hard. Um, we wanted to make sure that like we were walled off from those decisions so that we could change those decisions. And the reason we wanted to do that was because partially the lesson learned from the previous code base, but also this very real sense of, we truly honestly do not know what the answer is. We it could be Zookeeper, it could be etcd. It ended up being neither. It ended up being MySQL.
Oh,
at
I'd
the end
forgotten that
at the end
too.
of the day, MySQL won, which was hilarious. And the reason it won has more to do with the vagaries of the challenge of managing these things remotely, blah, blah, blah. Not important. But because we had that intervening abstraction, we were able to do that. And that came out of this sense of, we just don't know what the right answer is. So until we learn, let's just support them both. And actually, that was a good thing, because it prevented us from being tightly coupled, right? We wrote, and this was not that expensive. It really was not that expensive to build that intermediate like client layer. We did that. In fact, it was even more than that. The original architecture had all the components directly talking to the database, unmediated access except through a client library. And we were like, okay, the client knows how to talk to Zookeeper or etcd or what have you. And then we realized that like that made it really hard to orchestrate a rolling deploy. And so we ended up shimming in a server that was the intermediate between the client and the database. And in retrospect, this is like blindingly obvious, but you learn these things as you go. And it's interesting now looking back on it, that was totally influenced by, they have a message bus and they just attach the message bus. We should just do that, but with a database. Like, no, actually, you want a server. The world has solved these problems. You put a little server with a little client, you're set. You can change everything you want on either end, all good. Um, yeah, but you just roll with it. You learn and you change, and it's good. And it took like a month to go from direct connections to the database to now there's a server in the way. And it doesn't matter what database you're running because the server abstracts that away. And so then later when we needed to change to MySQL, no one else had to change but that server. Yeah.
Hang on. So you said it's blindingly obvious. And the thing that I feel like there's people out in the world that would say, yes, it's obvious. You should always architect a system that is
Right.
going to do this like this.
Right.
And the problem with that is you end up with this architecture that doesn't actually necessarily serve the real problem that the system is trying to solve. And so I don't accept your answer of well, it's blindingly obvious. No, it's only blindingly obvious
Exactly.
in hindsight after going through the whole journey, not because that's the right answer for all architectures.
Right. Exactly. It's blindingly obvious having gone through that journey. But at the beginning, do I shame and guilt myself over having made the wrong? Not at all. Again, it's all about allowing yourself to fail and then being honest and then learning. And which brings us back to fast feedback loops that tie you into reality are the key. Because reality will speak back. It will talk back.
Totally. Empirical evidence over
100%.
speculation every single time.
Every single time. Right.
Every single time.
Yeah.
You also talked about, as you sequenced work, sequencing so that the team would feel a sense of momentum. That's also not what a typical product manager might think about doing, but it bought you a lot of goodwill as things got to the messy middle, right?
I think so. I think so in retrospect, yeah. And I don't think at the time I was aware that this is what I was doing, you know? It's sort of the sense of like, what's the exciting thing here and how do we prove it out? And that was the driver. But looking back on it and understanding more how organizations work and how organizations get through those hard moments, being able to identify wins and celebrate them is really important. And that is what ended up happening. And so like it's funny talking, it's all coming back now. It's like, yes, we wanted to SSH into the container, but like I buried the lead. The main thing we wanted to do was like Windows support. It's like, how are we going to do that? And so this team spun up in New York, incredible crew of people. And, I was like, here's the lay of the land. If you build this, and this, and then talk to Windows containers, whatever that is, I think we're set. And they just went off and did it. And like the day we integrated, which was not that far after they started, like it was like, this is amazing. This is totally going to work. It was super exciting. Yeah.
So one of the weird things about Cloud Foundry, and coming back to that the product manager's role is listen to conflicting demands.
Yeah.
It is open source. We were using it internally, and then we were selling the enterprise product, which had the open source at the core and the proprietary bits layered on top of that. So you were building something that had three distinct entire sets of constituents, and then within each of those, everybody's got their own thing.
Yeah.
How did that make your life challenging?
It's funny because then when I became VP, it was like, okay, that was a very different set of challenges that emanated from that. But at the time, in the context of Diego, we were operating very much in the open source core part of the world. And even that Windows stuff ended up being open source. And so we did not end up bumping into that boundary very much at all. And I think that's to the credit of like the folks making decisions So Rob at the time was like, no, this is fine. This can be in the open source. This doesn't have to be where we draw the line, because we needed help. Like there were people from SAP, from IBM on the team. I mean, I've said me, we a lot. Like this was like a team effort. At its height, there were 20 of us, 4 of whom were named David. Um, um, from all of these different organizations working together to make this thing work. Uh, and it did. So for this specific project, that was not an issue. There were, and there would be later on, many questions about what's the right strategy. How do you add enough value that it's not just open source and all of this stuff? And that's like 7 other podcasts. You know what I mean? Like
That's yeah.
there's so many
We're not going
more.
to try to
There's
go there.
so many more things one could say about that. You can write as many simulation-driven tests as you want. You're not going to figure that out. But you know, clean architecture with seams that you could imagine proprietary things plugging into. That was the extent of that. And so, yeah,
Got it.
yeah.
So if we look at the timeline, I actually did go back through my records to find out. I have a note in my own personal journal about Diego development began in earnest in January 2014. So HM 9000 would have been then 2013,
Yeah.
and Ginkgo development. I also want to highlight the number of new things invented for this. Ginkgo being the behavior-driven Go framework for testing, that you kind of like slid that right by, but investing in writing a whole test framework and open sourcing that turned out to be one of the most critical things to contribute to success. But coming back to this timeline, so started January 2014 and was officially 1.0, which meant that DEAs, the original, were yeeted out in November 2016. So it was almost 3 years from birth to complete replacement, with a whole bunch of milestones along the way. And when I think about rewrite projects that I've heard about, 3 years is a typical time frame, but they aren't necessarily designed with the idea that you're actually in productions way earlier than that. I don't remember, when did we first have the first production, including Pivotal's production payload, but any production payload on a Diego node?
I want to say, and I don't remember clearly, certainly within our hosted environment that we were running, well within the first year, we had something running in production that you could opt into. Possibly within 6 months, if I'm honest, but I don't remember exactly. I think within a year and a half, customers could opt into the beta and start running workloads alongside the DEAs. And then one of the reasons it took so long to deprecate was because we needed customers to upgrade so that we could then say, okay, we now have everyone running on the new stack, and now we can formally say the old stack is gone. But I think within the first 6 to 12 months, it was running production workloads in Anger. Within the Pivotal environment. Yeah.
Totally. Okay, this has been amazing. I know that we could keep going for another 3 hours just unpacking lessons learned, but I wonder if maybe the best way to kind of bring things, land the plane, if you will, I would love to know if what your advice would be to anybody who's embarking on their own rewrite project. I know you've said a lot of things, but if you were to distill it down and say, here, you're about to go off on a journey, here's what you need.
Yeah. Don't be afraid to fail early, fail often. Allow reality to speak back to you and make those changes. I think paradoxically, if you fail early and often, you will succeed in the bigger picture. Invest in stuff that seems boring and tedious, like tests, and tests that connect you to that right aspect of reality that you need to be connected to in order to validate whether or not the thing is working. And then I would say the last thing is consider whether you need to do pixel for pixel rewrite, truly, or if it would actually serve you and the organization to go a little bit beyond that and start to see the fruit of your labor sooner, so that you and the team can celebrate, and so that the organization can feel enthusiasm that this is going to be worth it when they get there. Yeah, that
I
would
am
be.
so grateful to you. What a wonderful trip down memory lane. I had
Yeah, I
forgotten
know.
so much of
I had
what you
forgotten so
said.
much as well.
And
Yeah, yeah,
oh, I think it's a great story, and one that, I certainly hope that people will listen to who are about to embark on their own journey, because it was a wild success. It remains the core of
yeah,
Cloud Foundry.
yeah. To this day, kind of crazy. So,
Yeah.
and I'm thankful. It was a great experience, and the team was amazing. I mean, you mentioned Ginkgo, but like Concourse is born out of this.
Oh, yeah.
Alex Sirachi,
Yep.
a separate container executor. People know about Docker, but at the time we also had this thing called Garden, which also Alex wrote, came out of this. So many Go libraries for managing things, low level things came out of this, and just this real team effort, like solving these problems together and banging our heads against the wall until we finally shipped it. And we did, and it was great. And we had customers upgrade completely unaware that they were driving the plane, they're flying the plane at altitude, running mission critical apps, and we changed their engines for them. And we weren't even there. And that is like so proud of what this team managed to do, what the whole organization managed to do. Like that story never really got told, but it's an incredible story. Like,
That's amazing.
yeah, it's just incredible. And like that didn't add a lot of time. That constraint actually may have been why we ended up succeeding.